Okay, taking a look at this. Let's say we have 4 times n equals 8. Well, to solve that, we know we have to divide both sides by 4 to get n by itself, right? So what if we have a fraction in front of the variable? What are we going to do then? So like this one, I have 2/3 times n equals 4. So how am I going to get n by itself? Now, you could come in here and divide both sides by 2/3. That goes away. But do you know how to do 4 divided by 2/3 now? Yes, you could use a calculator, put 4 divided by parentheses, 2 divided by 3, and get your answer. But there is a better way, okay? Whenever I see a fraction, the key is I want to create a 1 here. I want everything to go away and create 1n. So I say to myself, hey, what could you multiply 2/3 by to create a 1 there? Well, it's going to be the reciprocal of 2/3. Remember, when you take a fraction, you flip it. So if I flip the 2/3, I get 3/2. And notice the 3 cancels with the 3, 2 with the 2, and I get a single n here. But if you multiply that left by 3/2, what do you have to multiply the right by? 3/2. Now, to multiply fractions, no big deal. A couple ways I can do it. Let's just do the easiest way for right now. Just imagine that whole number 4 is the same as 4/1. 4 divided by 1 is 4. You could cross out like I did over here, but let's just multiply across the top and multiply across the bottom. 4 times 3 is 12. 1 times 2 is 2. And what's 12 divided by 2? 6. I guarantee you 2/3 times 6 gives you 4. So let's say we have this problem. You could divide by 2/5. You could change 2/5 to a decimal and divide by it. But the best way is to say, hey, let me just multiply. Whenever there's a fraction, I'm going to multiply by the reciprocal out front. So I'm going to multiply by 5/2. Everybody would cancel and you'd be left with n. But since you multiplied the left side of the equal sign by 5/2, you got to multiply the right-hand side by 5/2. You just put that over 1. And like I said, multiply across the top, 40. Multiply across the bottom, 2. And 40 divided by 2 is 20. So there we go. All right, the next one. How am I going to get rid of multiplying the variable by 3/5? Multiply by the reciprocal. Do it on both sides. Everybody here cancels. 3 with 3, 5 with 5. And here, I multiply across the top, 10. Multiply across the bottom, 9. So it's just 10/9. Now, I could change that to a mixed number of 1 and 1/9, because if you have 10 people put in groups of 9, you'll form one whole group with one guy left over out of the 9. So that's how we sort of solve for a variable whenever we have this fraction out in front of it. Now, let's take a look at this. Look at all these fractions that are equal to one another. You agree that 2/4 is equal to 1/2, and 2/3 is the same as 4/6, because top and bottom both multiplied by 2. 4/8, well, if you ate 4/8, you've eaten half of it. But here's what's interesting to notice when two fractions are equal. Notice that these multiplied equal those multiplied. Those multiplied are 12. Those multiplied are 12. Those multiplied are 8. Those multiplied are 8. Now, technically, the math term is this is called the means extremes property. It comes from Europe. But you guys probably call it, I think elementary school, they might call it the butterfly effect. Cross product is another thing that it's sometimes called. Now, please note, this is only true when the two fractions are equal. Notice we don't do it when we're multiplying or anything like that. Now, knowing this fact, let us solve equations like the ones below with ease. So if I have two fractions equal here, which I do, I know these multiplied will equal those multiplied. And then we can solve for x, because otherwise you're just going to be plugging in numbers. It's going to take you all day long. So let's just use that little fact we have here. So I got 4 times that whole x plus 3. Now notice I put it in parentheses because it's 4 times the whole piece equals 3 times that whole x plus 5 piece. Now it becomes a problem we've done plenty of times. I'll distribute my 4 through to each of these. That gives me 4x plus 12 equals, distribute my 3 through, 3x plus 15. And now subtract get all my variables on one side. So I'll subtract 3x, x plus 12 is 15. And now move my number over. And I'll see that x is 3. And you could plug it in there. 3 plus 3 over 3 equals 3 plus 5 over 4. 3 plus 3 is 6. 6 divided by 3, that whole thing gives you a 2. 8 divided by 4 gives you a 2. Yep, that's the value that'll make it true. All right, let's take a look at this guy. These multiplied will equal those multiplied. And again, that's true because the two fractions are equal. So 10 times an x plus 1 will equal 8 times an x plus 2. Distribute through 10x plus 10. Distribute the 8 through 8x plus 16. Subtract your 8x from both sides, getting your variables together. 2x plus 10 is 16. Now move my number over. 2x is 6. Dividing by 2 gives me my value of x is 3 again in this situation. 10 divided by 3 plus 2. 3 plus 2 is 5. 10 divided by 5, 2. And on this side, we have 8 divided by 4, 2. It works out again. Now, what about one of these? Well, notice that what I need to do is I need to distribute this 2/3 through. Okay, and this is going to be one of our problems. This is actually problem 6. I'm going to give you one more here with problem 6. I need to distribute that 2/3 through. So I do need to think, okay, that's 2/3 times 12x, which is just 12x over 1, right? So again, multiply across the top, 24x. 3 times 1, 3. What's 24x divided by 3? Well, 24 divided by 3 is 8, so this is 8x. I now need to do 2/3 times 18. Well, that's just 18 over 1. 2 times 18, 36. 3 times 1, 3, so that's just 12. Equals to 6x minus 8. This is really just a lesson on multiplying fractions and numbers. So now we subtract 6x from both sides. I get 2x minus 12 equals negative 8 because that goes away. And remember, you have a negative there. I now add my 12 to both sides. 2x is a positive 4. Divide by 2, divided by 2, x is 2. Now, we had a lot of things there that we learned, so we might need to go back and relook at this to make sure we understand everything. But this is section 3-2 that we're doing in algebra now.